Hey everyone, welcome to another coding in JavaScript lesson on Hatch. Today, we are going to build this solar system project. We are going to learn about the mathematics behind circles and circular motion and use that knowledge to make objects move around each other in circles. So let's get started. We are going to actually build and design the entire game by ourselves as well. So to do that, we are going to open up an empty project template in the Hatch workspace. And for that, you have to open up hatchxr.com. Let me close this window here. And once you are on hatchxr.com, you can open up the hatchxr workspace by clicking on this Code with JavaScript button or the New Project button here. So when you click on the New Project button, it will open up a new project template. Now, here it is asking me an unpublished project was found. Do you want to reload that project? I'm going to click on No. It may not ask you that if you had not opened up the HatchXR workspace before, but if you had worked on the HatchXR workspace before and had not saved your previous project, then it will ask you that question. You can click on Yes if you want to open up the old project that you were working on, and you can click on No, open up the empty Hatch workspace like the one that you see here. So let me just full screen my window here. So now that the HatchXR workspace is open, you can see the scene here contains a box, a sphere, and a cylinder. And I don't need any of these objects in my game. I'm going to design the entire game by myself. So I can delete these objects here. To delete an object, you just click on the name of the object and press the delete button on the keyboard. So you see the box gets deleted. Now similarly, I can delete the sphere, I can delete the cylinder. Now you see there is a player object. Player object is a representation of yourselves in the game. Alright, so you cannot delete the player object, and I'm going to keep the light object because the light makes everything visible. But again, I do not need the ground object here. This gray plane that you see is the ground object. I do not need that ground object, so I can delete the ground object as well. Now, to build the solar system project, I'm going to start by adding the sun. The sun is the center of our solar system, and we will start by adding the sun. So to add the sun, you can click on this 3D models button on the top. It says 3D models here. When you click on this, it will give you the option to add different types of complex 3D models. Here, I cannot see a sun model, so I can use the search bar to type sun here, and you see, now it shows me different 3D models available for the sun. I can click on any of these objects to add in my game. I'm going to click on this sun object, this one. So I click on the plus sign, and you will notice that the sun object appears on the left panel. And the sun gets added inside the game as well. But to know that an object has been added in my game, knowing that its name has appeared on the left panel is enough. So now if you click outside, you can close the window and you can see the sun model present in your game. Now for this game, I'm going to place the sun at the center of my world. So I'm going to set the position of the sun object to 0, 0, and 0 in x, y, and z values. So you will notice that when your sun object is selected, on the right hand side, you can see the properties of your sun object. And you will notice that it has a position property, and position has three numbers, x, y, and z. So x has some value, y has some value, and z has some value. You can type the numbers that you want here. So I'm going to type x position for the sun to be 0 and press enter. And then similarly, I can type the y position of the sun to be 0, press enter, and then the z position of the sun to be 0 and press enter. So now you can see that your sun has been placed at the 0, 0, and 0 position in this world, at the center of this world. Now you will notice that this camera is literally on top of your sun. Camera is going to help us view the solar system. So we want the camera to be positioned far away from the sun. To do that, we can click on the player object on the left panel here and then increase the Z position. Or in the design of this game here, you can click on this blue arrow. You can move your mouse over the blue arrow and hold down the left button of your mouse and then drag the camera behind like this. Okay, so this moves the camera behind. But let's look at the Z position that it updated. It updated the Z position of the player to 4.3. I don't think that's far enough, so I'm going to set the Z position of the player to 10. And that will move the camera farther behind. And that looks good enough for me. Alright, so now that the player is out of the way of the sun, we can now increase the size of the sun, because the sun is the largest object in our solar system, so it needs to be really huge. To increase the size of the sun object, we can increase the scale. So you will notice that the properties of your sun contains the scale having the x, y, and the z values. You can increase the x scale to increase the size of the sun in the x direction. See, I can increase the width of an object by increasing the x scale number. Similarly, I can increase the height of an object by increasing the y number. See? And then I can increase the z scale of an object by increasing the z number. So you will see that as you increase these numbers, the size of the sun increases in those directions. Now I want the sun to be a properly spherical object. To do that, I want to keep the x, y, and z numbers the same. So I will keep the x scale to 5, the y scale to 5, and the z scale to 5. And this makes my sun big enough and uniform enough in all directions. Now with this done, let's add the earth object. So just like we added the sun object, we can click on this 3D models icon here and search for an earth object. So type earth in the search bar and it will suggest you some good 3D models of the earth object. Now you can add any of these objects in your game. I am going to add this earth model here. So click on the plus sign and you notice that the name earth has appeared on the left panel, indicating that earth object has been added in my game. So if you click outside here, you can see that there is an earth model now present in the game. But I cannot see the earth model properly. That's because there's not enough light in the game. So I'm going to add a light to increase the brightness of all the objects. To add the light, you can click on the lights object here. And when you click on the lights menu, you will see it provides you the option to add different types of light objects. I'm going to add an ambient light. Ambient light is like a bright light that increases the brightness of all the objects in the game. So if you click on the plus sign here, you will notice that now the earth becomes more visible and even the sun's brightness has increased a bit. Alright, so now that this is done, let's place the earth in front of the sun. So what I want to do is, I want to make the earth move around the sun in a circle. And circle has a property called radius. Radius defining the distance of the center from the boundary, right? So the radius in which I want the earth to move around the sun, you can define it to be any value. I'm going to keep the radius to be 10. So for now, what I'm going to do is, I'm going to keep the x position of the earth as 10. And then I'm going to keep the y and z position of the earth as 0 for now. So now that we have placed our earth object, let's add some more objects in this game. So I'm going to also add the moon object that will be behind the earth for now. So I'm going to click on the 3D models here and search for a moon object. So I'm searching for moon, and now you see it provides me with the option to add different types of moon object in my game. So I'm going to click on this moon object, and when I click on the plus sign, you will notice that the moon name has appeared on the left panel, indicating that the moon has been added in my game. So if you click outside now, you will notice that there is a moon object present in the game. Now, just like we placed the earth 10 units from the sun, what I want to do is I want to place the moon 2 units behind the Earth. So I want the moon to move around the Earth as well. And I want the radius in which the moon moves around the Earth to be of 2 units. So I know that the x position of the Earth is right now 10. So if I want the moon to be 2 units apart from the Earth, then the x position of the moon needs to be 12, right? So I can place the moon at the x position of 12 and keep the y and z positions to be 0. Now you will also notice that the size of the moon currently is same as the size of the Earth. Let's reduce the size of the moon. So just like we increase the size of the sun by increasing the scale in the x, y and z values, we can reduce the size of the moon by reducing the x, y and z scale numbers. So I can change the x scale of the moon to, let's say, 0.3, and then same goes for the y and the z values. So y number to be 0.3 and the z number to be 0.3 as well. And now you will see that the moon has become quite smaller. The scene still looks really empty. So what I want to do is I want to add some stars in the background. To add some stars in the background, you can click on this environments option. And when you click on the environments option, it will provide you with an option to add star system to your project. So if you click on the plus sign here, it will add some stars in your game. This looks really nice. Alright, so we are going to keep the design of our game simple. So we are going to keep this design of our game. And now let's go to the code window and let's make the Earth and the moon move around the sun and the moon to move around the Earth. Okay, so click on the code window here. So once the code window opens up, you will notice that currently I cannot see my Earth and the moon in the game here. That's because the camera is really close to the sun. We can go to the design tab and move the camera farther behind. So I can click on the camera object here and we set the Z position of the camera to 10. We can set this to 20 and press enter. And now your camera is farther behind. So now if you switch to the code window, we can see the Earth and the moon along with our sun. Alright, so let's start coding. So what we want to do is, we want to make this Earth move around in a circle around the sun. To make an object move around a circle, we need to understand how exactly is a circle defined in mathematics. So let me show you the properties of a circle that we can use to make the Earth move around in a circular path. So let me open up a whiteboard. Now we are going to start by understanding what exactly is a circle. A circle is basically a collection of points such that the distance of all of those points is the same from one specific point. And this point is called the center of the circle. Meaning that if I were to draw a circle here, this circle is nothing but a collection of a lot of points, right? And what do these points have in common? The fact that the distance of all of these points is the same from one point, that's the center of the circle. If this point C is the center of your circle, and you were to find out the distance of all the points on this boundary from the center, all of this distance would be the same, and this distance r is called the radius of the circle. If you increase the r value, it will give you a bigger circle. If you reduce the r value, it would give you a smaller circle. Alright? So to make an object move around a circular path, all you have to do is define a center point and define a radius. And then as time passes, all you have to do is ensure that the distance of this object stays the same from the center, and it will move around the object in a circular path. Make sense? So how do we code this exactly? What do we write in our code editor? So let me show that to you. I have the drawing of a circle here on a coordinate plane. So you see I have the x number line here and I have the y number line here, and there is a circle drawn here. Now this circle has a center point C that has the x and y position as A and B, meaning that when you draw the circle with this center C, the center C has the x position of A here like this, and this distance is the distance B. Okay, so now when you take any point P on this circle, let's say we have taken a point P here, such that the x and y position of this point P is x and y. Okay, so now you see when I draw the x position here like this and the y position here like this, what do we see? You can see here that this distance is A, right? And this distance is x. So what exactly is this distance? This distance is x minus A, right? This is your positive x-axis, and this will be your negative x-axis. Similarly, this is your positive y-axis, and this is your negative y-axis. We are only doing this in x and y plane. When we code it in 3D, we can just introduce the z axis again. Okay, so here now see, the center C has the x position A and the point P has the x position as x, meaning that the distance in the x position is x minus A, right? This difference, this red line difference, this red line has the length of x minus A. And then similarly, if the y position of the center C is called B, so this distance is B, alright, and the y position of this point is y, meaning that this entire distance is y. So the length of this line, what exactly is the length of this line? This is y minus B. So now, if you look at this triangle here, look at this triangle very specifically. We know that the distance of the point P from the center C is radius r, right? So this length is r, and this length is y minus b. This length is x minus a. And what do we see here? This is a right angle triangle. This triangle has this angle as 90 degrees. So if you zoom into the triangle here, so I have drawn the triangle separately. Now I have the center with the position AB and the point P with the position XY. And we know that this line has the distance x minus a, has the length x minus a, and this line has the length y minus b. And this is a 90-degree angle. So this is a right angle triangle. And for those of you who are familiar with the Pythagoras theorem, they will know that in a right angle triangle, we can write the square of this length, the square of the longest length on the right angle triangle, as the sum of the square of the other two sides. So you can write x minus a square plus y minus b square is equal to r square. Alright, so see, what do we know here? We know that the position a and b, and we know the radius r of the circle. So for all the x and y that satisfy this equation here, if you are able to find out all the x and y, you will basically end up with a circle around the point a comma b. That's the point C. Okay, so this is how a circle is defined in mathematics. Now, if you put a and b as 0, then you end up with a simpler equation that says x square plus y square is equal to r square. This is a circle that's centered around the origin of your world, around the center of the world. Okay, cool. So now that we know about this equation, we can use this equation to make the earth move around the sun. But there is a slightly simpler way to write this, and that's using the concepts of trigonometry. I know most of you may not be aware of what trigonometry is, but I just wanted to give you a basic idea of how we can use trigonometry to write the equation simply. Okay? So you see, in a right angle triangle, if you have a right angle triangle ABC such that the angle B here is 90 degrees, and then you define the lengths of all the sides of the triangle as, let's say, P, Q, and R. Okay, so I have this length as P, this length as Q, and this length as R. And then I'm defining this angle as alpha. All right, so there is a branch of mathematics called trigonometry, and there is it's nothing complex, it's just a bunch of new functions in mathematics. And one of the functions defined in trigonometry is called cosine of the angle alpha. Cosine of the angle alpha is defined as the distance p divided by the distance r, like this. And then you have another function called the sine of an angle alpha, that is defined as the distance q, the opposite side divided by the longest side. And the cosine is defined as the adjacent side divided by the longest side. Okay? Now for different angles, sine and cosine functions have different values. For example, I just have a table here to show you that your angle alpha can be anything, right? 1 degree, 2 degrees, 3 degrees, it can be any value. And for all the values of all the angles, sine and cosine functions have their own unique values. So for example, if alpha is 0 degree, then sine of 0 degree is 0 and cosine of 0 degrees is defined as 1. Sine of 30 degrees is 1 by 2, cosine of 30 degrees is defined as root 3 by 2. Sine of 45 degrees is 1 upon root 2, cosine of 45 degrees is 1 upon root 2 as well. And then similarly, there are other definitions. Now, see, we don't need to calculate the sine and cosine of an angle. Our computers already know how to find out the sine and cosine values of an angle. Our computer knows how to do these calculations. So how do we use the knowledge of these functions to define a circular motion? See, in this circle, actually, let me show you in this triangle itself. Let's take this triangle, okay? So we have the triangle here where the distance is r, this is the center C that has the x and y coordinates as a and b, and we have a point on the circle P which has the coordinates x and y. So we knew that this distance is x minus a and this distance is y minus b. So let's take this angle, the angle that P is making with the center C from the x-axis. Okay, let's call this angle as alpha. Now, what can we say? We can say cosine of the angle alpha is equal to x minus a divided by r. Just like here, we said cosine of the angle alpha is the adjacent side, P divided by r, right? So we can say cosine of the angle alpha is x minus a divided by r. And similarly, we can say sine of the angle alpha is equal to what? Opposite side divided by the longest side. So y minus b divided by r. Now, if you rearrange these equations, you will get x is equal to a plus r times cos of alpha, and y is equal to b plus r times sine of alpha. See? Now look at what do we know and what do we not know here. We know the center of the circle, we know the radius of the circle, and our computer knows how to calculate the sine and cosine of any angle. So as long as we keep on changing the angle over time, we will be able to find out new x and y points on the circle where we can move our Earth object to, right? So let me show you here. So let's say this is the center and our Earth starts from here. Okay. Now over time, if we keep on just increasing the angle alpha, right? If we keep on increasing the angle alpha, what will happen? After some time, my Earth would be making a different angle. And then as the time increases, the angle, I'm saying we keep on increasing this angle. So we know the distance r, we know the center position a comma b, and our computer knows to find out the values of cos of alpha and sine of alpha. So as long as we input this new, keep on updating the angle alpha, we will be able to define the position where Earth is supposed to be at any point of time, right? So we are going to do this. This is what we are going to write in our code editor. So let's do that. Let's go back to our code editor. So we are going to start by defining the radius in which the Earth is going to move around the sun. So I'm creating a variable called radius and I'm going to give it a value of 10. Okay. So 10 is just the distance I want for the Earth to move around the sun. You can give any other value you want here as well. And now what I'm going to do is I'm just going to create a timer. Click on the timers here and click on create timer. So you see you get a timer function. And what do we need to do here? We need to set the x and the y position of the Earth object, right? So I say Earth dot set x and Earth dot set y. Now we need to give some values inside the round brackets of set x and set y for Earth. What values do we need to give here to make it look like the Earth is moving around the sun? Yeah. So first of all, we need to define the center. The center is the sun's position. So let's create two variables called center x, and this is going to be the x position of the sun object. So the sun object's x position is sun dot get x, right? And similarly, we can create a variable to store the y position of the center, right? So let's say let center y is equal to sun dot get y. So see, these center x and center y are your a and b values that we need here. Yeah, and we have defined the radius variable as the r here. All right. So now what we can do is we can create a variable called angle and give it a value 0 in the beginning. Okay. So now what we have to do, we can just say set the x of the Earth object to what? To the center x value plus the radius variable multiplied by what? Multiplied by the cos of the angle, the cosine of the angle. Now, how do we tell our computer to find out the cosine of the angle? So, to tell our computer to find out the cosine of the angle, we can go to the math category here. You see on the left panel, you have a function called math. And if you click on this, it will give you different mathematical functions that you can use while coding. And here you will see there is a function called cos. Just click on this. And now you see this line of code has been added that says math.cos, and inside the brackets it says 1, right? So math.cos is how your computer can calculate the value of the cosine of an angle. and the angle that you need to find out the cosine for is written inside the round brackets here. Okay, so see, what we can do is we can just say it like this. I'm just going to put all the brackets in one line so it's easily readable. Now you see it says earth dot set x to center x plus the radius multiplied by math dot cos of 1. It says 1 right now. We have to change it to angle because this is the angle variable that is going to track what angle earth has rotated, right? So we just write inside the round brackets of math.cos the name of the variable angle. Okay, now I can copy this entire line of code from set x, control C, and paste it inside the set y function. And all I have to do is I have to change center x to center y, and where it says math.cos, I can just delete the cos and write math.sin. So just like math.cos tells our computer to find out the cosine of an angle, similarly, math.sin tells your computer to find out the sine of an angle. Now, once we have written this, now what do we need to do? We also need to ensure that the angle keeps on increasing over time. Yeah? So after moving the earth to this position, then the next time these two lines of code runs, we need the earth to move to a different position. So we need to rotate the angle. We need to increase the angle. So let's say I want to increase the angle by just 1. So I say angle plus plus, right? So angle plus plus will increase the value of the angle by 1. And now let's see what happens when we run the code. Now you see, as your code starts running, your earth is moving around the sun, right? But it's moving at a very weird pace. That's because we are first of all making the earth move every 1 second. And then the angle is also increasing by 1 unit. That's a very large angle. So let's change the value with which the angle will increase, and let's reduce the value of time after which we move the earth. So let me reset the code here. And here now I'm going to say, rather than running the timer again and again after 1000 milliseconds, run it again after 20 milliseconds. And after 20 milliseconds, I want the angle to just increase by 0.01. Okay, so see, I'm not saying angle plus plus anymore. That's because angle plus plus would increase the angle's value by 1, and I want to increase the angle's value by just 0.1. So I have to say angle, then plus equal to is an increment operator that increases the value of a variable by the number you have defined on the right hand side. So angle plus equal to 0.1 will increase the value of your angle variable by 0.1 units every time the timer runs. And then whatever this new value of the angle is, the next time the timer runs, your earth will move to that angle's position in x and y. Okay, so now if you run the script, you will see your earth moves around the sun, and it's moving very smoothly, and it's moving in a proper circular path, right? See how simple it was. How simple was it to make the earth move around the sun in a circular path? Now let's also make the moon move around the earth. Okay, so let's reset our code and let's see what new modifications we may have to do to make the moon move around the earth. So just like the earth was moving around the sun, so moon will move around the earth. So we have to define the radius of the moon's path. So the radius of earth's path was 10, right? So we are going to create a new variable, let, and I'm going to call it m radius and give it a value of 2. So we know that we have kept the moon 2 units from the earth, keeping in mind that we want the moon to move around in a circular path of a radius of 2 units. So m radius is a variable that I'm creating to keep the track of the moon's radius around the earth. That's 2 units. And now what I can do is I'll have to create two new variables to keep track of the moon's center, right? The center of the circular path in which moon is going to be moving. So just like the earth was moving around the center, that was the sun's position, the moon is going to move around the earth. So I'm going to create a new variable called m center x. And this is going to be the earth's position, earth.getX. Okay. And then similarly, I'll create a new y center position. So m center y, and give it the y position of the earth. So I'm going to call it earth.getY. Cool. So just like we created the center variables for our earth object, we are creating center variables for the moon object. Now then, one last thing that's remaining is the angle that moon would rotate around the earth. Now see, we can use the same angle, but what happens is this angle is defining how fast the earth is moving around the sun. And we know that earth moves around the sun in 365 days, but the moon moves around the earth in just 29 days. So moon moves around the earth at a faster speed than the earth moves around the sun. So we will have to create a new angle variable, m angle. And we can start it with a 0 value, but where we are increasing the angle by 0.1, we will have to increase the m angle by a larger value, right? To make the moon move around the earth at a faster speed. So now that we have created these variables, let's write the code to make the moon move around the earth. So all we have to do is, inside the timer, we can now write moon.setX, right? We have to set the x and y position of the moon. So moon.setX and round brackets. Inside the round brackets, we write the center, right? So m center x plus the radius. So m radius multiplied by math.cos of m angle. And then end the line with a semicolon, and then write the same for the moon's y position. So moon.set y to m center y plus m radius multiplied by math.sine of the m angle, right? And then we increase, just like we are increasing the angle of the earth, we have to increase the angle of the moon. So we write m angle plus equal to, and now in place of saying m angle plus equal to 0.1, we can say m angle is equal to 0 plus equal to 0.05. 0.05 is larger than 0.01, meaning that the moon is going to rotate a larger angle in 20 milliseconds than Earth, right? So moon will move around the Earth at a faster speed. So let's see if this is working or not. So let's run the script and see what happens. Now you see, something unique is happening here. While the Earth is moving around the sun in a circular path, and your moon is also moving in circles, but the moon is not moving along with the Earth. And that's because what's happening is the center around which the moon is supposed to move is also moving, right? So you see, when we define this m center x and m center y, we define this outside of timer. So they are not changing over time. But in reality, the center position of the moon is also changing over time. So what we have to do is, in place of defining the center like this, we will have to copy these two lines of code and put it inside the timer. Why? Because the center around which the moon is moving is changing over time. So we have to keep on defining new center position for the moon. as the Earth's x and y position. So here you see I'm defining let m center x and let m center y, but I don't need to use let anymore because I have already declared the variables on the top, right? So I can just remove the let word from here and just give the m center x and m center y the new Earth's x and y position. And now, if you run the script, you will see that your moon is moving around the Earth while the Earth is moving around the sun. So now, what you can do is you can add more planets, make the planets move around the sun, add more moons to the planets, and make those moons move around their respective planets as well, and build an entire solar system project by yourselves using the same logic, right? So for planets, you just have to define their x and y position like this and keep on increasing their angles. Now, different planets move at different speed, so you can define their angular speed by this changing this 0.01 number to something smaller or something faster based on how far the planet is from the sun. So I hope you guys learned something new in this. I hope you guys can try out something new with the math library functions that we learned today, and see you guys in the next lesson. Bye bye.